The Retort Season 1 presents expert views on the BTWC and CWC and the issues they face. This project is the product of a collaboration between Professor Lijun Shang, Professor Malcolm Dando and Dr. Brett Edwards. This initiative has been funded by the London Metropolitan University Rescaling Fund 2021, which was awarded to Professor Lijun Shang. We are grateful for this support.
Hello and welcome to this series of talks on the subject of chemical, biological weapon disarmament and non-proliferation. In this series, we will be hearing from a wide range of experts as we look towards the two major review conferences which will be taking place in coming months. In each talk, you will hear from a respected expert who will outline key opportunities and challenges in making pragmatic and holistic progress on this issue globally. This project has been kindly supported by the London Metropolitan University.
Thank you very much for being invited to give this talk on the future of chemical and biological security. Security. What is it that we mean with security? Well, when I use security here, I would understand security as a multi-layered system from the global to the individual. It is addressed by multiple instruments or mechanisms that mitigate insecurity. Of course, the next question, what is insecurity? Coming from multilateral treaties to an individual level of ethics and morality. And it is building security means to prevent the misuse of agents and technologies. This misuse would in this case be the insecurity. And to this end, security-related activities include the identification of risk. I mean, first, of course, you have to know what it is that threats come from, how they look like. Then you would have to look into the norms, what norms can be applied, what is around, and how will they develop in the future. Norms does not only mean treaties, legal norms, but also moral norms, behaviors, and so on. You can see threats by pure theoretical possibilities. A technology might open the possibility for misuse at a very theoretical level, but you might know, well, this is, although we know this technology now, still pure science fiction, and you need so many efforts, money, know-how, skills that maybe not even the most powerful actor, let's say the richest, most industrial state on earth in a powerful weapons program could use these technologies to build a chemical or a biological weapon. So this is the level of possibilism. Things are possible, but no one really believes that they would come. Then second layer is plausibilism, and this is basically where we move and where we are here when we talk about biological and chemical security, because the third level, likelihood, only applies when you can really calculate it, like smoking and cancer or traffic accidents, where you have so many cases that you can statistically determine how likely it is, really in metric terms, say, well, if you have these so and so many cases, you will have so and so many incidents. This is not possible, luckily, in the area of chemical and biological security because we don't have so many cases. But what we have is an idea. I mean, everyone thinks in scenarios, basically, and everyone would think of, well, what of this theoretical level of possibilities is what we think is plausible. Chemical and biological security also in the two treaties do meet and overlap. Toxins belong both to or are covered both by the Bioweapons Convention and by the Chemical Weapons Convention. So the Chemical Weapons Convention was only negotiated and come into force in the 1990s, but this overlap was already clear during the negotiations to the Bioweapons Convention in the 1970s. So you have here this intersection set of these two, and that for most of the time covered toxins and not much else. So then there is a development of this field. You have chemistry and biology growing, and in the 2000s you have these larger spheres. And you can then think, well, does this intersection set also grow the same way? Will you still have the same proportions here? And I would think no, because still you have only these toxins, and while you have a lot of additional knowledge in chemistry and a lot of new chemical substances, and you have a lot of new technologies in the area of biology that could lead to misuse, like genome editing, and so I will not count them now here, but yeah, it's a lot of new stuff, but here the intersection set was still toxins. So this intersection set was basically shrinking proportionally to the 2000s, while the technologies as such were growing. But you see, the picture has developed because now this intersection set, it might not be that big, but it has been growing because additionally to the toxins, we now have new technologies in drug development, in protein structure analysis, and also protein function prediction. We have systems biology, so we know a whole lot more about bioregulators. All these belong to this intersection set. So the convergence of B and C is growing, and it will grow further. And what it is also important to see is that it's not, well, possible. You should not see those two spheres alone today, but also include cyber, artificial intelligence, machine learning, deep learning, material sciences, biosynthesis of chemicals and chemical synthesis of biomolecules, and others into the picture to see, well, convergence is growing on many fields. So recent science and technology development enlarged the proportion of the intersection set in parallel to an emerging convergence with further technology fields, and that of course has a big impact on the future of biological and chemical security. In contrast to chemical arms control, biological arms control is much more based on prevention than on disarmament. So bioarms control is preventive arms control. There have been some cases of non-compliance, but most bioweapons programs were disarmed already at entry into force of the Bioweapons Convention, and we also know only very few cases of bioweapons use. The Chemical Weapons Convention, since its entry into force, was for larger past focused on disarmament. So there have been many large declared stockpiles of chemical weapons that were to be destroyed. And we also have seen repeatedly use of chemical weapons in war, and also for attempted or completed assassinations. So the main goal of biosecurity policy is to ensure that bioarms control stays as it is a preventive endeavor, and no bioweapons programs become will be there. And chemical arms control, well, this is about to change with the now more or less completed destruction of declared stockpiles. So the future task of chemical arms control is to restructure the whole field, including OPCW as the international organization and its task towards a more preventive approach. Yeah, in this regard, the arms control cultures might merge in the future. And I'm going to discuss the future of chemical and biological security along the lines of the subjects and objects of B&C security, agents, technologies. Second, the treaty regimes, treaties and their institutions. And third, the security debates. It's about the future and it's about current developments and what we might see as future tasks, new technologies, and so. But the disclaimer already here: do not forget the traditional chemical and biological weapons. What has been established in the past will not go away. So we will still in the future have possible potential problems with the chemical agents that already killed people in the First World War, and also like all the past bioweapons programs included anthrax. This is a threat that will not go away and will also be there in the future. Agent-related developments, however, in the biofield means that, as I said, there are few relevant newcomer pathogens. So if you look into the CDC lists of relevant agents, there is not much change, I think, since the Bioweapons Convention came into force. Ebola came here and few others. But basically, if you think on biosecurity along the lines of pathogens, there was not much change basically. But there are, of course, engineered agents at the door. I mean, you've heard about gain of function research. That means to give pathogens resistance against antibiotics or vaccines, or to make them more lethal, or able to infect other hosts. And so this is going to be, this is happening now already in the labs for pharmaceutical research, and that will pose a greater threat to biosecurity in the future. And another future trend might be, we see today that there is more in-depth research in the area of bacteriophages. I've heard a talk on that on the Spiez conference just a couple of weeks ago, and no one was really sure what concrete threat scenarios could be developed out of this, but people were quite sure that this is something one should have an eye on. Chemicals, weapons related, again, there's still a main role with the well-known agents, including Novichoks. I mean, that means newcomers, but they been developed in the 1970s already, and they will be problematic in the future as well. However, there are thousands of new chemicals being identified every day without them being screened on chemical weapons feasibility, however. So you synthesize many chemical substances every day, but for most of them, we don't know really about their characteristics, what they would do in the body. But yes, the sheer number of substances is growing exponentially. And machine learning also, and we've seen this in this recent article in 2021, it enables directed research for new toxic substances. That was in Nature Machine Intelligence. and researchers used one of their established softwares in drug discovery to, within hours, identify more than 40,000 chemical compounds that are closely related to VX. And this basically is also the bridge to the, and now we are at Boolean and again at the chemical and biological weapons related threats. So where you really have this overlap, this convergence of B and C and IT as well. Because the universe of peptides and proteins is prospectively getting under control. I mean, you might know this from gene sequences. They encode amino acids. Amino acids make peptides, and peptides make proteins. Very complex, large molecules. And for the time being, you couldn't really say which genetic sequence, or you could know what atoms would be in this protein, but if this protein here at this piece here at this edge would fall just into the other direction, it would have possibly a complete different function, and it was till now not really possible to say what exact form this protein that is encoded by in the genome will have. Or to use the example of the spike protein of the COVID-19 virus that was in the media the past years, if you have a sequence change, you might know that this would do something with the spike protein with the spike protein, and that this possibly has severe consequences on the characteristics of this virus. But in fact, you had to wait to clinical results to see what this new formed folded spike protein would really do, because function prediction was not yet possible. But that is something that changes in the future. In the near future, it will be much more easier to get from the genetic code to the exact form of these proteins and of the peptides as well, and so that you can get from rebuilding to targeted design pretty soon. And this is also important for bioregulators. These are large biomolecules, basically also most of them peptides, enzymes, hormones that are synthesized in the body as body's own substances, and they could, of course, also become administered as weapons. Apart from the well-established threats by pathogens, this seems to be the most relevant issue for the agent-related future of bio and chemical security, with challenges for regulators, states, and research and development stakeholders to reduce misuse potentials, because bioregulators could basically affect many functions of our body: blood pressure, temperature, do something to the central nervous system, and so on. There are a lot of possibilities, not only lethal, but also to maybe come up with bioregulator, chemical biological weapons that are non-lethal, or better to say less lethal, because non-lethal weapons are not really out there. So on the agent-related developments, a summary: agent-related challenges in CMB security will still come from well-known agents mainly. but gain-of-function research will increase the biosecurity threats from viruses and bacteria. Progress on the field of peptide and protein function prediction through synbio developments will create new challenges on the overlap of C and B agents. So yeah, and in the chemical area, you will see similar threats from IT-powered design of chemical weapons relevant molecules. Let's get to the future development of the treaty regimes, institutions, and other frameworks. First of all, treaty regimes do own institutions. These can be organizations, but also approved practices, rules, norms, and so on. So things that you would that have rather an abstract nature and are not so much physical institutes. The Bioweapons Convention and the Chemical Weapons Convention share some commonalities, as you know, but their differences predominate when it comes to the state of institutionalization and expectations for the future developments of these institutions. Let's start with the Bioweapons Convention. It is very obviously a treaty regime with underdeveloped institutionalization. There is beyond the ISU, these three staff office in Geneva, no physical institution. However, it has rule-based institutions which are seldom or maybe have never been used. Just recently, we have seen as an institute coming into action the formal consultative meetings under Article 5, very seldom used, the second time only. We can debate how the Russian disinformation campaign belongs into the context of biosecurity, but however, the institute as such was working. And then there's another one, the confidence building measures as an institute with also some shortcomings. We'll not go into detail here. Here are no changes in sight. So for the future, we'll talk about future developments. This will not play a role. Then there is also United Nations Secretary General mechanism, which applies for both the Chemical and the Biological Weapons Convention, but is a parallel mechanism that is not in the treaties, but in the United Nations at the level of the United Nations Secretary General. And there is, in fact, some development. There are exercises, tabletop and real exercises to enable experts to get this mechanism into life when it's needed and when it's requested. And yeah, this is one institute that will develop in the future, hopefully even more. And the Bioweapons Convention might have contributed to a world largely without bioweapons. I mean, you can say, we don't know if there would be more or less bioweapons without the Bioweapons Convention. We only have this one future. But I would say, well, it's quite likely that the Bioweapons Convention had some effect on the non-existence of bioweapons. And you might say, well, maybe it is fine like it is, and we don't need any institutions in the Bioweapons Convention. But I would doubt that, and I would be afraid that with the growing possibilities in biotech and in this convergent field with chemistry, in the future, you would urgently need working institutions. Otherwise, you would put the success of the convention at risk. Unfortunately, there are very few formal occasions where you can do institution building, and that is only a few conferences. The next one coming up in just a few weeks' time, and I'm a bit pessimistic about that, and think it's rather likely that status quo will remain the same. So what possible effects on the future of institutional biosecurity will the upcoming review conference have? Very likely, no, for sure, no treaty organization is going to come. Also, compliance mechanism is at least not to come at this review conferences. However, Ambassador Bencini of Italy, the president designate of the 9th review conference, said in a talk just last week that he thinks making a compliance mechanism and talks into that direction should be an issue in the next intersessional process. So there is hope that in the coming years, there is as a standing item of the intersessional process, the adoption of a compliance mechanism might be a topic. For many years, we had, as an institutional development, the idea that a science and technology board will come. And there have been many constructive talks in the past years. Again, I'm pretty pessimistic in this because I see the global political landscape, and I don't really believe in the states parties being able to adopt a science technology board, but I would rather be afraid that that this will be spoiled. What can happen is that the so-called Tianjin biosecurity guidelines for codes of conduct for scientists might be adopted. It is still a chance for agreement, but to again, sorry for putting again a bit of pessimism into this debate. This will only be able to develop into an institution of the Bioweapons Convention if it is accepted by the science community. It's a bit seldom a situation that that such code is being adopted as a top-down approach. Mostly behavioral codes for scientists are developed in the science world itself. But I do only hope that that this code will be read, understood, and implemented by researchers. Chemical Weapons Convention, I will be very brief here because the chemical weapons on the institution side has a lot of what the BWC is lacking. OPCW is a well-equipped and very competent treaty organization in The Hague. There are verification provisions in the treaty. However, one of these instruments, the challenge inspections, have not been used by now. There is a science advisory board to keep the regime informed on developments relevant for chemical security. To come back maybe to the bio S&T board. By now, there's simply no possibility to officially inform the regime about technical developments. There are side events and there are expert talks, but in fact, all of what has been said by scientists and side events will by no means become official knowledge of the regime. So if there is a talk about gain of function experiments and these other new technologies, it formally still stays outside of the regime, which of course would be changed with such a board, and I think that would increase biosecurity enormously. Also in the Chemical Weapons Convention, there is a similar code, or a code that can be compared to the Tianjin Code. The Hague Ethical Guidelines have been established, and so on. So on the institutional side, it looks quite good for the Chemical Weapons Convention. And well, I don't know. Also, there, of course, there are future developments needed, but not so much as in the Bioweapons Convention, I think. What is, I think, really desirable would be for both regimes, and I hope to see that in the future, and to make this a future issue for B and C security, it's de-siloing as requirement for institutional handling of threats in a world with more convergence, because convergence is really a pretty broad thing, phenomenon. It is important, I think, to intensify the ties to other treaty regimes, to enable effective reactions on security threats from issues just outside the regimes. For example, environmental issues, when you think of gene drives or transmissible vaccines, or horizontal genetic alteration mechanisms. There are certain threats to bio and or chemical security that I think are more tackled in neighboring regimes. There is some engagement of the OPCW science policy advisors, so the one now and the one in the past, also in the BWC security context, which is good. It's a very good starting point, and I hope to see that continued in the future. There is also other international organizations like the World Health Organization, the World Organization on Animal Health, the FAO, the 1540 Committee, and many others. They are present at BWC, and I would think, I'm not very often at CWC meetings, but I think also at these meetings, but they are present there. What I would, I would hope to see also a more context to environmental treaties and organizations, because as I said, for the case of gene drives or so, that would be really a treaty organization, a treaty where you have to come in contact with. And in the future, I would wish to get from exchange to joint action, to increase security in all of these fields. So I said I'm not going only. I will also talk about the security debates. So it sounds a bit more abstract, but I think it's quite interesting, and I think that this is where we will see also many. I hope so, at least many developments in the future. So the dual-use research of concern problem is, since the early 2000s, the main center of the debate in biosecurity. Gain of function, I mean, was just a recent experiments that this is really a relevant issue. The gain of function experiments at Boston University create a deadly COVID-19 virus. This is the main issue in biosecurity, risk-related research. And the drivers of the debate are, of course, the states parties, but very much the scientific umbrella organizations, such as the National Academies of Sciences, think tanks and university with dedicated biosecurity research programs, and so on. And Dirk makes academic research institutions, including the individual staff, are the main objects of biosecurity. Interestingly, industry, in contrast, is not yet much present in this debate, and let's see how this might change in the future. I've just mentioned already the Tianjin Biosecurity Guidelines for Codes of Conduct for Sciences that might be agreed on the 9th Review Conference, and I've already said that I have little doubts that this top-down approach, as a bit unusual way, will be successful, but I keep my fingers crossed that it does. Because in fact, the future of biosecurity still needs more awareness. I mean, we have this DIRC debate since the early 2000s, and still, I think that in many research institutions, the awareness of risk-related research is not really well developed. But yeah. On the other hand, of course, you could see that with educational programs, and so many institutions of education, research have been reached, for example, via the science policy interfaces and science diplomacy in governments and vice versa. Since this is really the center of the security debate, I would just urge to not to forget to prepare for the practical implication of security measures. You can't stop with awareness raising. In the end, you need rules, you need regulation in the narrow sense of meaning, and you have to be equipped to do inspections, to do controls. So please go ahead with developing the United Nations Security General Mechanism and peer reviews. And please do implement peer reviews at industry too. They have the possibility to do a bulk production, and it would be just for the case that we need it at one point in future, a very good idea, I think, to have developed mechanisms for industry review at voluntary peer review exercises in advance. So the chemical security debate is very much different from B. The DIRC debate is almost non-existent. There are security concerns debated in journals, for example, or most of them in the journal Pure and Applied Chemistry. But the context here is rather industry, in contrast to the B side. Industry as potential operators or suppliers of chemical weapons programs. And there are very few articles. There are some, but very few articles on risk-related research. And with the OPCW as implementing organization, security in the chemical field is much more a practical exercise than a debate being based on debating single cases of DIRC. Chemical weapons concerns are more on the level of large-scale weapon of mass destruction issues, and hence the industrial production facilities are much more in the center. Biological and chemical security should, and this is the end of my talk, should grow closer together where there is convergence in technologies and agents, and they should tie more with related technology fields, or to say it in brief, institutionalize the Bioweapons Convention and theorize and socialize security in the Chemical Weapons Convention. Biological and chemical security debates should inform each other. So include the DIRC dimension, including theorizing of security into chemical security, and make industry as the stakeholder with large-scale processing and own dedicated research facility a factor in debate of biosecurity. The asterisk means if there would have been a verification protocol and a organization as the OPBW as equivalent to the OPCW, the whole security debate could have developed pretty differently. Maybe we wouldn't see so much DIRC debate, but as in the chemical field, a more industry-centered debate. It is good that we have this debate on DIRC and gain of function related related security risks and threats. And so I would just wish that in the future they move closer together. Really continued failing institutionalization in the bioweapons prevention would put the preventive character of biological arms at risk. We need better institutes in the bioweapons convention, and I can only hope that states parties take the advantage of the 9th Review Conference and do something. I said I'm very pessimistic, but if there would be the chance for an SAB board in the future to formally inform the regime about future security threats, that would be really a great development, and even more restarting work towards a compliance mechanism. New security threats come mainly from the convergence of biology, chemistry, and other tech fields. And it is very important to choose wisely where and how to govern these new convergent issues. Since I would, on the example of these less lethal bioregulators that could be applied as weapons in the future, there is the risk that this is being covered only under the Chemical Weapons Convention as less lethal weapons for riot control, but in fact.
And all that's left for me to say is to thank Gunnar
really
very much for providing us with that
threat,
talk,
I would say,
and I look forward to
also
seeing you in
used,
future episodes.
Militarily, and so they have to be covered by the Bioweapons Convention as well. And also in the future, my last sentence, do not forget the established agents and technologies. They will still threaten our security in the future. Thank you very much. And if you have any questions, send me an email or contact me. Otherwise, my contact details will be provided in this video.
And all that's left for me to say is to thank Gunnar very much for providing us with that talk, and I look forward to seeing you in future episodes.